get started here. Sam?
Present.
Nate?
Here.
Sean Dowling. Sean's not going to be coming in today. Okay, so today we've got some good stuff planned. We're going to go over some functions and statistics and trigonometry and other math-related stuff, like addition. Okay? Okay, class. So first thing we're going to do today is we are going to talk about shapes. Okay? And we're going to talk about one specific shape that I'm going to show you here in a second. So can anybody tell me what shape that is?
I believe that's a triangle.
No, sorry, that's incorrect. It's actually a triangle. Triangle. Okay, so let's say I just name this triangle A, B, C for each of the angles, and sides A, side B, and side C. Can anyone tell me what the sine of angle B is?
Mr. Professor Martin,
Yes.
I believe that is incorrectly labeled.
Yes, I was actually testing you with the labeling. If I were to label it correctly, how would I label it?
I believe the little a would go across from the big A, the little b across from the big B, and the little, no, that's a little b,
Oh, yeah. Testing again. B.
and a little c across from the big C.
Fantastic. Okay, so can anyone tell me the sine of B in this case? Yes, Sam.
Professor Martin, no one can tell you the sine of B is not a right triangle, but you could use the law of sines.
That's right, the law of sines. Okay, so because I'm not sure exactly the logistics of the law of sines, Nate, why don't you come up to the board and you make up a problem and solve it for the rest of the class, and I'm just going to take a seat. So.
Okay, I believe the law of sines is
Well, thank you, Nate. That was pretty terrible. So you can go have a seat now. I guess we'll call that the law of sine lesson for today. Sounded like total crap to me. So I'm just gonna scribble this out. And all right.
well, Mr. Professor Martin, this law clearly states sine of angle A over A is equal to sine of angle B over B, which is also equal to sine of angle C over C.
Yeah, that may or may not be true. That's disputable. There's no proof. Well, look who decided to show up, Mr. Dowling.
Oh, and first of all, I was at the doctor's office.
The doctor's. That sounds like a bunch of crap to me.
Oh.
What is that? Smoker's cough? What have you? You've been doing drugs? You stoned right now? You got stoned before you came to school today, didn't you? You're stoned. You've been smoking marijuana. Marijuana cigarettes. Is that correct?
It's not.
Are you in a gang?
No, I'm not.
Do you have a gun?
No.
You can't bring a gun to school.
I don't have a gun.
You don't have a gun.
I don't have a gun.
So why were you at the doctor's office? Is your girlfriend
I'm
knocked up? Is that it? She's pregnant, isn't she?
No.
No?
I
Okay.
promise.
You promise? Now you're lying to me. Now you're telling me false promises. That's great. Have a seat. Have a seat. Be around to clear. Look at that. You're stoned. Okay, so if everyone could please get out their homework now. I'm going to be collecting homework at this point. Okay, let me see how you did on the homework, Mr. Brady. Looks like all wrong answers again today. And Mr. Kahneman.
I had a question on question 13.
Yeah, didn't we all? This looks like the same stupid mistakes that Mr. Brigham made. Were you two working together this weekend, or were you just copying him blindly?
No, it's away this week.
You were away. That sounds like fun. Crap. And Mr. Dowling.
I think it's good.
Yes, this does look good. This does look good. If it was opposite day, because these are all wrong.
Professor Martin, is there a reason why you threw our homework in the trash?
Because your homework is garbage. None of you know anything about mathematics. I studied mathematics for 2 years at junior college, and I think I know a little bit more than you. So we're going to move on in the book to the next chapter here. So if everyone could flip to the next page in their textbooks, that would be excellent. I'm just going to create some room here and get rid of all this law of sines mumbo jumbo. And, all right, we can move on. Yes, Sam, question.
Yeah, Professor Martin, how do any of these math concepts we learned today apply to real life at all?
Into real life. Well, for one, you take math in real life, so that would be one way that it may apply to real life because you're here and it's life. And another way is, well, sometimes you see lines in real life, like on the side of the road or something, or like the tree trunk might be vertical, and yield signs are triangular, and I saw one of those pulling in this morning, so that's, you know, applicable. So, yeah, there's just, you know what, I really don't have to explain myself to you, okay? I went to junior college, okay? I have a 2-year degree, okay? So you know what, you just shut up and listen, okay? You know what, this is ridiculous. You know, I can't teach kids with poor attitudes such as yours. This is absolutely, you know what, I've had enough. I quit. You teach the class now, Mr. Brigham, Mr. Real Life Brigham, okay? That's on you. You figure it out.